Hi guys! So today we're going to be talking about Chapter 5, Section 6, Graphing Linear Inequalities in Two Variables. So we're going to start off first with a little bit of review. The question is asking you to tell whether the ordered pair is a solution of system of linear equations. And so we have here the linear equations x plus y equaling to 8 and 3x minus y equaling to 0. The ordered pair that they're giving us here is 2, 6. So based off of the fact that I know that an ordered pair uses x, y, I know that my x value is always going to be on the left side. So my x value is 2, and my y value here is going to be 6. The next thing that I want to do is substitute that into my equations. So I get 2 plus 6 equaling to 8. 2 plus 6, that equals to 8. And so 8 equaling to 8, that checks out as a solution. And so we can say that 2, 6 is a solution for the linear equation x plus y equaling to 8. Let's check out the other one here. We have 3 times 2 minus 6 equaling to 0. 3 times 2 gives me 6. 6 minus 6 equals to 6, and so we have here 0 equaling to 6. Since that is also a solution, we can say that 2, 6 is a solution for the linear equation 3x minus y equaling to 0 as well. And so we can say that 2, 6 is a solution. So a solution of the system of linear equations. Okay. Cool. So let's try it out. Right here, we're asked to tell whether the ordered pair is a solution of the system of linear equations. The linear equations that are given are x minus y equaling to 6 and 2x minus 10y equaling to negative 4. And the ordered pair that's given to us is 8, 2. So I'll give you a few minutes to work on this on your own first. Okay. So again, right here, we're given x minus y equaling to 6. We also have here 2x minus 10y equaling to negative 4. And then again, our ordered pairs are 8, 2. So that tells me that my x value here is 8. My y value here is 2. And I can plug that into the equations. So I get 8 minus 2 equaling to 6. 6 does equal to 6. We can say that this is a true statement. We also have here 2 times 8 minus 10 times 2 equaling to negative 4. 2 times 8, that gives me 16. Negative 10 times 2, that gives me negative 20. And so I'm left with negative 4 equaling to negative 4. So we could say that 8, 2 is also a solution to the system of linear equations. Okay. Now let's try something a little different. Let's say we were asked to tell whether the ordered pair, the same ordered pair 8, 2, is a solution of the inequality statement where we have 2x minus 10y is less than negative 4. So again, I'll give you a few minutes to work on this on your own first. Okay. So here we have 2x minus 10y being less than negative 4. And the solution that we're given is 8, 2. So again, I want to write this into my inequality statement. So I get 2 times 8 and minus 10 times 2 is less than negative 4. 2 times 8 gives me 16. 10 times 2 gives me negative 20. And that's supposed to be less than negative 4. And I still get here negative 4 is less than negative 4. Now this is actually a false statement because negative 4 is not smaller than negative 4. They are equal to each other, but they're not smaller than each other. And so because of that, we have to say here that 8, 2 is not a solution when we have that inequality statement where we use that less than symbol. So if we're thinking about that information, then I have a question here. And the question is asking you which would have more solutions. The problems that we did in the beginning, where we asked the solution of the system of linear equations 2x minus 10y equaling to negative 4 and x minus y equaling to 6, or would the linear inequality 2x minus 10y being less than negative 4 have a more range of solutions? I'll give you a few minutes to write a response and explain why. All right. So over here, the first thing is we want to answer that because it'll give us a better understanding of what we're working with today. Now, 2x minus 10y being less than negative 4, that linear equation provides more solutions than the system of solutions for the linear equations x minus y equaling to 6 and 2x minus 10y equaling to negative 4. Now, the reason behind this is because the solution of the system of linear equations only gives you one solution. If we were to graph the linear equations x minus y equaling to 6 and 2x minus 10y equaling to negative 4, you would see that we would only get 1 point. In this case, if we have 2x minus 10y being less than negative 4, this can be any ordered pair where 2x minus 10y is less than negative 4. So if this solution here turns out to be less than negative 4, then it is still a solution to this inequality statement. And what that means is that rather than just getting 1 point, we're going to need to shade an entire region, a region where those ordered pairs will be less than negative 4. Or once you plug in those ordered pairs, you get an answer that's less than negative 4. And so because of that, right here, you're shown a system of linear equations. You see that you only get 1 point here, while over here, you're going to be given multiple points. So all these points that are shown here should be solutions where if you were to plug them into the x value and the y value, that's going to turn out to be less than negative 4. And so for today, we're going to be talking about how to graph linear inequalities starting with one variable first. So right here, we're asked to graph y is less than or equal to 2 in a coordinate plane. Now, the first step that I like to do when graphing out inequalities is I like to change my inequality statement to an equation, where right here, instead of having less than or equal to, I always switch it out with that equal to sign, because I know how to graph equations. So if I'm given y is equal to 2, I do know based off of review from before. So this is a little bit of review again. When you have a number equaling to y, we know that we're always going to graph out a horizontal line. So I always graph out a horizontal line at positive 2. if, for example, it was any number equaling to x, it would be a little bit different, where I would draw a vertical line instead. And that vertical line would be at positive 2 over here. So that's the first step that I want to do. I want to graph out y is equal to positive 2, since I know how to graph that out. So I have here my y-axis. Here is my x-axis over here. And then these are the points. I have 1, 2, 3, 4. 1, 2, 3, and 4. Down below is -1, -2, -3, and -4. And on the left side is -1, -2, -3, and -4. Now, based off of that, I can graph out that horizontal line. So I'm going to graph out a horizontal line first. Okay. Now, the second step is to determine, am I going to be drawing a solid line or is my line going to be dashed? Now, if it's a solid line, I have that symbol, either the less than or equal to symbol or the greater than or equal to symbol. If it's a dashed line, that means that I'm going to have the less than symbol or the greater than symbol. So right here, because of the fact that I'm given that less than or equal to symbol, I'm going to keep my image here as a solid line. And so the last step is to identify where the shaded region is. Now, I want to pick a point that's not on this line, but somewhere around it, and somewhere where it's kind of obvious to me that I'm either looking at the bottom of this line or the top of this line. I will choose, for example, let's say I'll pick the ordered pair of 2, 3. 2, -3. I know that this ordered pair is obviously below the line, and that kind of helps me identify where I'm going to be shading. And so we get here 2, -3. I know that 2 is my x value, -3 is my y value, and I want to plug that into the inequality statement that's given to me. So the inequality statement that's given is y is less than or equal to positive 2. And so I'm going to take my y and substitute it for -3. And then we're going to see if this is a true statement or not. So -3 being less than or equal to 2, that's a true statement. Now, because that's a true statement, that means this bottom area here is going to have all the solutions. And since it has all the solutions, that means that I have to shade in the bottom region here. So if one solution is working, then that means that everything on that side of the line is going to also be a solution. What that does mean is that also this area on top, none of these ordered pairs are going to be solutions to this inequality statement. And so it's important to understand that if, for example, like we did here, this ordered pair 2, -3 is a point to the solutions, that means that on the bottom side of this line, that shaded region is all going to be solutions to the inequality statement. You can also check it yourself by graphing out one of the points on top, and you're going to realize that it's not going to work out. So here I have, let's say I use the ordered pair 4, 4. This ordered pair is obviously being shown on the top of the line. And if I were to plug that in, so I have here 4, 4, my x value is 4 here. My y value is 4. If I plug that into y less than or equal to 2, you're going to see here that if I plug in the variable, the 4 to the variable, I get here 4 is less than or equal to positive 2, and that is a false statement. So because of that, it shows here that this solution is not going to be, or this point is not a solution to this line here. The only ones that are solutions are going to be any point given down below here. Okay. So again, let's try out another one. This time we're asked to graph x being greater than 2 in the coordinate plane. So again, I'm going to start off with my first step, which is to change my inequality statement into an equation. So I always change that greater than sign, less than sign, greater than, equal to, or less than or equal to sign to a equal to sign. So here we're given x is equal to positive 2. Again, I do know how to graph the equation x equals to 2, where whenever we're given x with a number or equaling to a number, I do know that that's always going to be drawn in a vertical line. So here I have 1, 2, 3, and 4. Over here is -1, -2, -3, and -4. On top I have 1, 2, 3, 4, and down below is -1, 2, 3, and 4. And so my drawing again is going to be vertical line going up and down at point 2. And then the second part of my step is to identify, am I going to have a solid line or a dashed line? Again, when you have a solid line, that means you're using the less than or equal to symbol or the greater than or equal to symbol. If it's a dashed line, you have a less than sign or a greater than sign. And based off of what's given, we're given a greater than sign. So that means that my line here needs to be dashed. So I'm going to erase these points, or erase the solid line and make like a dashed line here. Okay. Now, in this case, this drawing is telling me here that the shaded region could either be on the left side or on the right side of the graph. And I'll just pick a random point that's away from the line. So I'll pick something like -3 and +4. So here is -3, 4. This point is obviously being shown on the left side of the line. And I want to see if that's a solution or not. So again, I have here -3, 4. The x value is -3, the y value is +4. And my statement is x is greater than 2. So since we're using the x value, that means I'm going to plug in -3 and see if that's a true statement. So -3 being greater than 2, that is a false statement. So that means that any ordered pair on the left side of this line is going to be a false statement. But that also means that anything on the opposite side, so anything on the right side here, is going to be a true statement. And so I'm just going to shade in this area right here, because all of these points show that this is going to be points that would be greater than +2 by looking at the x value. Okay. And so that would be the end of my graph. Now we're going to try graphing a linear inequality with 2 variables instead. So we're going to be asked to graph negative x plus 2y being greater than positive 2 in a coordinate plane. So these are exactly the same steps. The first step that I want to do is change my inequality statement into an equation. So rather than having negative x plus 2y being greater than 2, I'm changing that to negative x plus 2y equaling to positive 2. And I want to identify what the slope is and what my y-intercept is. And to do that, I need to write down my equation in that format of y equaling to mx plus b, which means I need to get my y completely by itself. Now to get y completely by itself, I'm going to add x to both sides. When I add x to both sides, I can drop down the 2y. I get 0 plus 2y equals to x plus 2. And I'm left with 2y equaling to x plus 2. Next step is to divide 2 on both sides. And that would cancel out that 2 over here. So I'm left with y equaling to 1 over 2x plus 2 over 2. And that would just be y equaling to 1 over 2x plus 1. So my slope here is 1 over 2. My y-intercept is positive 1. And we can change that to that ordered pair 0, not negative 1, 0, 1. Now I can graph out my graph here. So I have the image. Here is that's a not so straight line. Let me make this look nicer. That looks better. That's my y-axis. This is my x. Ooh, that's pretty high. I want this to be lower. My x-axis. And then I need to draw out my points. So I have here 1, 2, 3, and 4. Right side is positive 1, 2, 3, and 4. Down below, negative 1, 2, 3, and 4. And on the left side, negative 1, 2, 3, and 4. And I want to plot out the points. So 0, 1. That point is right here. So this is 0, 1. And it's telling me that I need to move up 1 and move to the right 2. So I'm going to move up a point, and then I'm moving to the right 2 points. So 1, 2. So this will be my other point. And I want to create a line. So here I have a line being created. This is the line going up, and this is the line going down. Okay. I think that's straight, is it? Nope, that's not straight. One should be like this. Okay, there, that's straight. So as you can see here, my line is at a diagonal, but we can also see here that whatever the solution is, it could be either on this bottom area or on the top area of this line. And so it's still visible to see whether where the shaded region will be later on. But before we even get to that, we have to look at the second step. So second step, solid or dashed line. Right here, if it was a solid line, again, it's the less than or equal to, greater than or equal to, or it's the less than or greater than sign if it's dashed. And so here we're given a greater than symbol. So again, I need to erase the line, and so it makes a dashed line rather than a solid line. So I made dashes in my line here. Then the third step is to identify the shaded region. So to find the shaded region, I need to pick a point that's pretty obvious. It's either on the bottom or on the top of this image. And I guess I'll just work with the bottom one, just because there's no real reason. So right here, I'll try out 2 comma negative 4 and see if that works. Oops, that's negative 2. 2 comma negative 4. So here I have 2 comma negative 4. 2 is my x value, negative 4 is my y value, and I want to see if this is a solution to the inequality statement. So my inequality statement is negative x plus 2y being greater than 2. I'm going to plug in 2 into the x value and then negative 4 into the y value. And so I get here negative 2 minus 8 is greater than positive 2. Negative 2 minus 8, that gives me negative 10. And so that is not greater than positive 2. So this is a false statement, which means that any ordered pair on this bottom area is definitely not going to be a solution. And so because of that, I can say here that the solutions are on the top of this line, not on the bottom. I'm just going to shade in this area. And again, you can always check to make sure that, let's say your math work was incorrect, you can always check. So over here, I can choose, for example, negative 3, positive, oops, thought that would be positive 4. I'm trying to get positive 4 here. So negative 3, positive 4. You can plug that point in to see if it is the correct solution. So here I have negative x plus 2y is greater than 2. This is my x value. My x value is negative 3. My y value is positive 4. So I get negative 3 plus 2 times positive 4 being greater than 2. Negative times negative 3 is giving me positive 3. 2 times 4 gives me 8. 3 plus 8 gives me 11. So I get 11 is greater than 2. And that is a true statement. So as you can see, if you pick any point over here on this top, you're going to get a solution. And so that is how you graph out a linear equality. So hopefully this helps. Hopefully, and then also good luck.